Learn how to make an attachment system for your guns like what you see in games like Call of Duty and Battlefield. Today we're going to be creating a 3-slot attachment system, including the UI that we're going to build with UI Toolkit. If you prefer to use UGUI, the same concepts are easily applicable in that system. We're going to largely be leveraging systems that we made in Part 8 and Part 9 of the gun series. If you haven't checked those out and you're not a really advanced developer, probably going to want to check those out first. Hey, Chris here from LlamAcademy, here to help you.
Me?
Yes, you! Make your game dev dreams become a reality by helping you make a highly customizable, configurable attachment system for your guns. When we think about what is an attachment, it's really just a set of modifiers to apply to a gun. Maybe we attach a name, description, and some icon, some stuff like maybe when it's unlockable, some cost of in-game currency that it costs to unlock, and then maybe also understanding that this is the one that's currently selected. Once we have this data model, we can allow our players to, per slot, configure different attachments that should be applied. There's some changes to our gun scriptable object that we need to do to allow us to remove and reset it kind of stuff. But with what we built so far, the majority of this code that we need to do is going to be UI focused. Again, we're going to be using UI Toolkit in this video, but you can implement this in UGUI as well with the exact same concepts. With the UI put together, the user can select different attachments that should apply different modifications to the gun. Once the menu goes away, the user closes it or clicks apply, something of that nature. We'd want to apply these modifications to a base gun scriptable object, not the current one. We tried to do it to the current one. The user could select between different attachments and become overpowered because they just keep stacking modifiers on modifiers. Luckily, because we have most of the core systems already worked out, there shouldn't be really any magic happening here. It's just linking stuff together and presenting it on the UI. And remember, the full project's on GitHub, available to everybody for free. If you felt I covered something too fast and just pausing, rewinding didn't work out so well for you, or I didn't cover something in enough depth, you can always check out the full project and inspect it on your own pace. That said, let's hop in and get started. We're going to start with making the UI because without a UI, it's impossible for our players to make adjustments to their guns and attach different attachments to customize their gun according to their preferred gameplay style. Like I already said, we're going to do this with the UI Toolkit. It's very easily translatable to UGUI if you're familiar with that system and would prefer to do it in that. The core concept of what we're talking about here doesn't change. I've already created a UI document called Attachment Document, set up a couple of styles so we get what you see here so far. The intention is if we click that X button, it'll close the menu and the user's going to press Escape to bring this up. This is not going to be like an introduction to UI Toolkit. This is going to be really focused on implementing this specific UI. You can of course adapt whatever styling and whatever you need to match your game. The key components of this is that we have this visual element. This visual element has flex grow 10, so it wants to take up a lot of space, and we're going to set up the main content of our UI underneath that. You saw already what this is going to look like at the end, where we have a gun icon on the left, some slots in the middle, and on the right would be the slot options. So we've got an icon, a slot container, and an options container. These names are also important because we're going to query for them in our script. For the icon, we're going to set it to have a width of 150 pixel, a height 150 pixels, flex string 0, flex grow 0. This is going to set a pretty static size for this icon, and then we're going to attach a class to these icons, and these classes will adjust the background image based on the class name that's applied. So for example, the M4A1 is going to pull a background image using a URL, that's just a path to that texture. And when we use this URL, we also need to include the file extension. So we have /assets/textures/m4a1.png. However many guns you have, you can follow the same pattern. Whenever this page or screen is loaded, you can attach the gun name as a class name to this icon. And as long as you have the USS defined, it'll change that background image for you. Our options and our slots, we're actually going to use the same control for, and we'll just hide an icon whenever we're showing the actual attachments. That way we only need one UXML template to support both UI elements. So I'll create one under Assets, Resources, UI, Templates, Attachment Slot. And I'm putting this in the Resources folder so we can load it at runtime, because when the application is playing to dynamically load something, it should be in the Resources folder, or an asset bundle or addressable or something like that. The Resources is just the easiest way for us to get this up and running. In here, we'll adjust the canvas size to be 450 width, 150 height. That's approximately the size that I'm looking for this to be. And in here, it's not going to be very complicated. We're going to have an image on the left that's an icon. It's going to follow the exact same pattern pattern that we were just talking about for the previous icon for the gun, where we're going to attach a class name that's going to apply a background texture. Same concept here. I have a visual element that I have flex row on, so it will take up as much space as possible within the bounds of the container. We'll also attach flex row to align items across instead of vertically. Since this is a new UXML document, we also need to attach the root styles here. We'll drag in a new visual element and give it the name of icon. It's going to work the exact same way as that gun icon. We'll drag in a visual element, and as a child of that, add in 2 text labels, one called name and one called description, also with the name and description classes. And a third visual element that's going to be like the right arrow that will give the class of chevron right. For attachments, we'll be hiding this one. On the name, I've also attached the HR class, which basically like border bottom. Here's what the USS looks like for that. We're going to set that background image of the chevron. We're going to have a cool hover effect whenever we go over it. That might come out of the box if you use a button instead of visual element like what I've done here. The name and description, we're going to set to be slightly larger fonts. So the name will be 24 pixels, description will be 16 pixels, and we'll have that border bottom on the HR. At the end, it looks a little bit something like this. Now that we have that UXML, we're going to have a backing class for that to allow us to set up that document. We're going to put that in the LlamAcademy Guns Demo UI namespace. We'll make it extend a visual element, and I'm going to make some public properties that are populated by querying the children based on the name of the element. So we'll have a public label name with an arrow that says this.q of type label, looking for name. So whenever we try to access the name, we're going to first query for this label. And the label we're looking for is the one that's called name. We'll do the same for a public label description, querying for a label called description. We'll do a public visual element icon that is also querying for a visual element called icon, but we have 2 of those. So that's going to return the first one. Our public visual element button is going to query for visual element. Again, you could use a button instead of a visual element here as well. We're going to pass a null for the name because it also is called icon. And for the class, we'll pass chevron right. We'll then add a private static visual tree asset called tree. And we want this to be static because we only really want to load it one time. Loading stuff from disk or for an asset bundle or whatever takes some time. So when we're creating new ones, each one's going to have the same UXML, so it doesn't really make sense to have multiple of these. It's not like they vary per instance. To make sure this works in the UI builder, we'll make a public new class, UXML factory, that extends the UXML factory of type attachment slot. We don't need to define anything in there, it works automatically. We also need a default constructor, so we'll make a public attachment slot, and in the default constructor, we want it to just load the visual tree asset. So we'll say get tree asset in there. In code, it's much more convenient to be able to pass in the name, description, and icon name. So if we're not using the UI builder, we'll probably use a second constructor that would accept those parameters. In there, we do the same thing about getting a tree asset. Let's go ahead and define that now as private void get tree asset. We'll check if that tree is null. If it is null, then we actually need to do the loading. So we'll check if the application's playing. If the application's playing, we'll use resources.load visual tree asset at the path UI templates attachment slot. This path may vary if you didn't follow the exact same path that we used a minute ago. Remember, when using resources.load, you don't need to pass the full path, you only pass the subfolders within the resources. You also don't need to specify the file extension. If the application is not playing, that means we're doing this in the editor in the UI builder, so we can use assetdatabase.load asset at path, and for that, we do need to specify the full path, so assets/resources/UI/templates/attachment/slot.uxml. We also have to include the file extension, and that will give us our visual tree asset. We'll do something a little bit weird to check again if the tree is null. If it is, we'll log ourselves an error saying that there's an invalid path specified to the visual tree asset. That probably means we've moved the file or deleted it on accident. And that also means this class won't work. If the tree is not null, then we can do tree.cloneTree this, which will copy the UXML into this visual element. Now that we can load that tree, whenever we call the fully qualified constructor, we want to set up this thing to apply the name, description, and icon names to our elements. So we'll call a function called setup, passing in these parameters. And if we use the UI builder, we'd expect to query for it and then call the setup function in whatever class has these attachment slots embedded already. This is just a pattern that I like to use to make sure it works in UI builder and in our code. On setup, we're going to set the name text to be the name, the description text to be the description, and we're going to add the icon name to the class list. This is where that magic is going to happen, where we're going to provide basically a class name as the icon name, and it's going to dynamically associate some background image to this visual element. We need to make a data model for our attachments so we know we can apply them, they can show up on the UI, and we probably configure this using an editor script of some kind. So public class attachment, it's not a mono behavior, it's not anything, just a standard C# class. We want a public string name with a getter and setter, a string description, a list of modifiers to be applied. Maybe you'd want like an int cost and an int unlock level, something like that, so you can have them progressively unlockable. And probably we also want to know if this is currently selected. So we'll have a public bool is selected, again with the getter and setter. Make a default constructor. In the default constructor, maybe we just set the modifiers to be a new list. And also a fully qualified constructor that accepts the name, description, modifiers, cost, and unlock level. And we'll also add a public void add modifier that accepts a modifier and just adds it to our list. I don't know if we're going to use that add modifier, but it's probably pretty convenient. We'll hop over to our attachment document controller, which is the backing class for our main page here. This is where we're going to add in the slots and the attachments and all that kind of stuff. So we're going to require component type of UI document, and we'll define a private UI document that we'll assign on awake. Something I like to do is immediately add a hidden class if this page is going to be not visible immediately. That way I can still work on it and see it in the UI builder, but at runtime it's immediately hidden from us. You can use USS styles like hidden and visible to toggle opacity like this. Anything that we have to regularly query for, I like to make a class member variable, so we'll make a private scroll view, slot scroll view, and we'll query for that on start. Here's where those reusable components come in. On start, we're going to create 3 attachment slots, one for a barrel, one for the grip or the handle, and one for the ammo type. You can of course have as many or as a few of these as you need for your game. We'll make an attachment slot, slot equals new attachment slot, saying that the name is barrel, the description is standard issue, and the icon is ban or standard, something like that. And we'll add it to the scroll view. We'll repeat that process for each slot that we want to have, making sure not to reuse our object because later on we're going to assign some delegate functions and we want to make sure that whenever we pass the attachment slot, we're passing the correct one, not one that's been reassigned. This thing has to know when it's visible and when it's not. It may also be useful for some other class to be able to tell when this is visible. So we're going to make this a public bool is visible that has a public get and a private set. And we're going to use the field serialized field attribute to make that visible in the inspector. On awake, since we're making this thing be hidden, we'll make sure to set that to be false. And on update, we're going to use a new input system to show and hide this UI document whenever the escape key is pressed. So we'll check if keyboard.current.escape_key.was released this frame. If you're using the old input system, it's just input.getKeyUp keycode.escape. Gives you the exact same functionality. We'll check if it's visible. If it's visible, we'll hide it. Otherwise, we'll show it. We'll make a private void hide. Set is visible to be false. Add the hidden class to our root element and remove the visible class from the root element. Show will do the inverse, where we'll set is visible to be true, add visible to the class list, and remove hidden from the class list. That's just going to transition in and out the opacity. The problem that we're going to run into is this thing shows up, but our input controls are still going to be working, so I can have the menu up and still move around and shoot, which isn't really a good experience. And there's many ways that we can handle this. I'm going to do it maybe a simplistic way that might work for your game, or you might need to implement something a little bit more robust. I'm going to add a serialized field private mono behavior array of input controllers. What we're going to do is just disable these mono behaviors, whatever types they are, whenever this thing is visible, and re-enable them whenever this is no longer visible. That way, whenever it comes up, it'll disable any input or input processing. Whenever it's hidden, we'll re-enable all of those things. So on hide, I'll call toggle input controllers. I'll do the same on show. Then we'll define that as a private void, toggle input controllers, and we'll iterate over each of the input controls in the input controllers and just set input control.enabled equals not is visible. If you're using the new input system where you're handling events that are raised by that system, especially if it's based on the starter assets input, there's a little bit more work that you have to do other than just disabling the script. Even a disabled script still catches those events. Since we are using the starter assets input, wherever we're trying to apply something based on the input that we've received, we're just going to check if the script is enabled. The same goes for on application focus. We want to make sure that we only want to do something in the script if it's enabled. If you're querying the input directly like what we did on our attachment document controller, then this step isn't really necessary. So we should now have something that can pull up and close whenever we press escape, but we can't really do anything on this menu yet. We need to be able to select a slot, but right now we don't really know what slot we're talking about. So we'll make a new public Enum slot, and we'll define 3 options: barrel, handle, and ammo type, which correspond to those 3 attachment slots we already created. And for each one of these slots that we've created on start, we want to register a callback of type click event to the button, which is that chevron right arrow button thing on the right side. Using UI Toolkit, this is how we can encode, add handlers to any visual element. So slot.button.register callback of type click event. We're going to pass in a function here. We actually don't care about the click event, so we'll use the discard naming of underscore for the argument, do a fat arrow, and say we're going to handle slot click slot.barrel and pass in the slot that we just clicked on. In there, we'll later on be able to set up which attachments and show which attachments are associated to this particular slot. Repeat the exact same process for slot 2 and slot 3. You'll notice I did a little typo and said slot 3 will still pass in slot, so I need to correct that real fast. We'll define that function as private void handle slot click that accepts a slot, click slot, and attachment slot slot. This name is a little bit confusing, so I'm going to come back and change that in a second. The first thing we'll do is clear the slot selection classes, because whenever we click on one, we probably want to indicate to the user which one did they click on, at least with this type of UI layout. So we'll clear the existing selected ones, and then we'll say slot.add-to-class-list selected in private void clear slot selection classes. We'll just remove from class list selected for each of the children of the slot scroll view. After we've shown the user that they've clicked on this thing, we want to build those attachment options for the slot. So we'll do build options for slot, passing in the click slot, and I'm going to rename that to be type just so I have to stop saying slot so many times. Now is really where this starts coming together. We need some way to be able to associate a slot in which attachments are available for a particular gun. Covering making a system like that is a little bit out of scope for a single video. I think this would be like an hour long if I needed to do that as well. For now, so we can see how can we do this and how can we make the UI work and actually make the attachments modify a gun, we're going to define a private static read-only dictionary of slot to attachment array. And in your game, you might have a dictionary of dictionaries for each gun has some kind of loadout configuration. In here, we're going to stick it pretty simple where any gun has the same possible options. Obviously, that's not very dynamic for your players and doesn't really make a lot of sense just mechanically speaking. Just to see the process, we're only going to define one option for each slot for the time being. We'll define this all inline where the barrel has a new attachment array with only one size, new attachment called standard. The description is standard issue. It has no modifiers. And the unlock level and cost are not relevant for what we're talking about. We're going to say that this is default selected, so is selected is true. I'll give handle and ammo type the exact same configuration, and we'll come back later and add some more, so a little bit more interesting. Back down in build options for slot, we're going to query for the option container on the document root visual element. Remember, this is that root container that has a back button and a scroll view, and we want to populate all of the attachment options underneath the scroll view. I'm going to make it fade in to the right, make sure that's focusable, and then we're going to pick it on position. Since I have this thing kind of overlaid on the left side, this is important so we don't accidentally click it when it's invisible, and we can click it after it is. We're going to iterate over all of the mock attachments for this particular type for the slot that we clicked on. Remember, that's an array of attachments. So we're going to get the current index, index equals I, attachment equals mock attachments for the particular slot type at the particular index. We're going to create a new attachment slot based on that attachment, passing in the attachment name, description, and here's where the magic of the USS comes in. We're going to use the attachment name to lowercase, replacing any spaces with hyphens, so it becomes kebab case name. So any of our attachments, we should define a USS class with that exact name, all lowercase, hyphenated, with the background image set to the path of the texture that should represent that attachment. When we click on the slot, we want to say, yeah, that's the selected one. So we're going to do slot.register callback, click event. Again, discarding the event because we don't care. We're going to call a function called handle change option, where we're going to pass to it the attachment slot that we just clicked on, the slot type that we're clicking on, and the particular index that this attachment is. That's why we need it to be index, not I. If we use just I, it'd be mutated, and whatever we pass this delegate would always be the last index of our attachment array. We'll check if this particular attachment is selected. If it is, we're going to give it the selected class, and then we're going to hide that chevron right. Remember, we're using the same component that has an arrow. We want to remove that arrow because there's no submenu to go to for the attachment. The last thing we need to do is actually add these into our UI, but we don't have the option scroll view yet. So if we scroll up, we can define an option scroll view to be the option container queried for a scroll view, and we don't have to pass any arguments there because it's the only scroll view as a child. Then back down, we can do option scroll view.add this attachment slot. Let's define that private void handle change option, where that accepts our attachment slot, the slot type, and the index. And in here, we want to iterate over all the children of the option scroll view, but we don't have the option scroll view available. So we can either change our function here to accept as an argument, or because we have to query for this all the time anyway, maybe it's better to make it a class member variable. So we'll define a private scroll view option scroll view. In build options for slot, we'll check if the option scroll view is null. If it is, we'll query for it. If it's not, then we want to clear all of its children, because we don't want leftovers from the last time that we built the options to still be there. Back down in our handle change option, remember we're trying to actually change the attachment that the user selected. So we're going to iterate over all of the children of the option scroll view, remove that selected class, and add selected to our current attachment slot UI. That's the same concept as what we were talking about for the slots. We want to indicate to the user which one's selected and remove ones that are no longer selected. Now we need to update our mock attachments dictionary to accurately represent the new selection. We can do this by iterating through it, finding all options for our current slot that are selected, marking them not selected, and then going again. Instead of going back and forth all the time, it's a little bit more convenient to have a second dictionary of selected attachments. So we'll define a private static read-only dictionary of slot to int called selected attachments that has the 3 slot types, barrel, handle, and ammo type, all saying that the 0 index is selected by default. Back in our handle change option, our mock attachments, we want to deselect the previously selected one, which we can tell from our selected attachments dictionary is selected attachments indexed by the type. So we can do mock attachments indexed by type, indexed by whatever the value of selected attachments indexed by type is, which by default will be 0. We'll set that to be selected false, and we'll select the new one just by doing select attachments indexed by type equals the index, and we can easily access the particular attachment as well by doing mock attachments indexed by type, indexed by index, dot is selected as true. You'd obviously want to persist this type of data per gun for your player. That way they retain their loadout between runs of your game. If you don't know how to persist data across runs of your game, we got a video that goes in depth on how you can do this using the JSON data format. Link in the description, card on the screen. We're almost there. We can select some attachments, but we can't apply them to the gun. This introduces an interesting new challenge because modifiers just modify a gun scriptable object, right? We did that in part 8. Since an attachment just has a list of modifiers, the player just starts toggling between attachments. They could become very strong, have no recoil, have a bunch of different bullet effects all happening at the same time. It's not really good. We need a way to apply the modifiers to the base gun, not to the already modified gun. That means we basically need to be able to reset our gun and remove a gun. So in our gun scriptable object, we already have a function called spawn. So let's make a public void despawn, which we'd call anytime we want to get rid of our gun. Maybe we're toggling between guns. Maybe we just need to apply attachments. Maybe we're picking up a new gun and discarding this one. We're going to, in this case, destroy the model immediately because we're going to do a bunch of other stuff in the same frame. We're not going to just use destroy where Unity would destroy it at its earliest convenience. We're going to do some other cleanup like clearing our trail pool, clearing our bullet pool, and setting null references to our shooting audio source and our shoot system. Our player gun selector is kind of the thing that's managing the gun so far, so we're going to just keep extending that one for now. In Awake, that's where it does the setup. So what we can do is expose a public void apply modifiers that accepts an array of modifiers, despawn the current gun, destroy that gun scriptable object, and then call awake again, which will do that setup process for us. After it's been set up, we can then iterate over all the modifiers and apply them to that gun. Remember that also creates a copy of our scriptable object, so we're not modifying the base anymore. We're modifying a copy of the base. Now that we have some way to apply our modifiers to our gun, let's get a reference in the attachment document controller to the player gun selector with a serialized field private player gun selector. And whenever we hide the menu, we'll apply those modifiers. I don't like the idea of doing it every time the user clicks because probably they're going to select more than one at a time. They really will only notice that this thing's been applied after they've closed the menu. You may want to do it earlier if you're going to show like stat bars or something for the gun. In some case like that, you may want to apply them immediately. The problem is we don't have a convenient way to get the modifiers for the currently selected gun, so we'll call a function called collect modifiers. We'll define that private modifier array, collect modifiers. This one's not too bad. We'll just do a list of iModifiers, modifiers to apply. To be a new list, we'll iterate over each of the key value pairs in the selected attachments, and we'll just add all of the mock attachments keyed by the key and value of the key value pair, dot modifiers. We'll add all of those to our list, and then at the end, return the modifiers to apply to an array. It's important that we can show our cursor whenever the menu is shown. So on the hide function, we're going to do cursor.lockState equals cursor_lock_mode.locked and cursor.visible equals false. That's going to hide the cursor and make it locked to the center of the screen. Whenever we show this menu, we want to do the inverse, making cursor_lock_state lock mode none. You may also use confined and set the cursor visible to be true. Let's add some new attachments with some different configurations. For the barrel, maybe an option is called long barrel that reduces the time it takes to reach maximum bullet spread. The modifiers to achieve that is just a single float modifier. Let's say it takes 25% longer whenever you equip this attachment, and it's going to modify the property shootconfig/max spread time. Again, we don't care about unlock cost or unlock level in this particular demo. Another option may be on the handle. We have an attachment called the potato grip that reduces the time it takes to reach maximum spread and reduces vertical spread by 10%. To do that, that's two different modifiers. One is a vector3 modifier that takes a new vector3, saying it doesn't modify the x, modifies the y by 0.9, and modifies the z by nothing. And that's going to affect the shootconfig/spread property. And again, to reduce the time it takes to reach the maximum spread, we're just going to do a new float modifier, 1.25 times the shootconfig/max spread time. Maybe we'll make a second attachment option called enhanced scripts that just across the board reduces spread by 25%. The modifiers for that will just be a float modifier, reducing the shootconfig spread multiplier by 0.75. That works if we're using the texture-based spread, which I ignored on the previous ones. Right now we're using simple spread, so it's not really important. And a vector3 modifier to modify the shootconfig/spread by 0.75 in every direction. For ammo type, if you watched part 8, this is not going to be surprising at all. The only difference here is we're going to use an impact type modifier, and because we're not using some system where we can bind our scriptable objects directly here, we're going to do some kind of hacky thing for the impact type modifier. The rest of this, we can have a float modifier to adjust the weight. We can use an impact effect replacement modifier to add collision handlers for a new explode, and I'm using the exact same values I used in part 9, so I'm just copy pasting those. We can do the same concept for frost rounds as well. Now the top quality hack is we're going to have two serialized fields for private impact types, one an explosive type and one a frost type. On awake, we're going to directly access this dictionary and override the impact type modifier, which is the first one in the list, to set the value that's going to be applied to be these two types appropriately. So again, this is only for our demo because we don't have some management system to handle these impact type associations. As I'm saying this, I already feel the comments coming in, so maybe I'll make a video about that. If you think that's going to be really important, you'll get value out of that, leave me a comment and we'll see what I can do about that. You can see the USS here. For all of these attachments, I have the kebab case, lowercase, class names that point to a particular texture for each of these. So whenever we click play in the inspector, we'll see these show up correctly. I guess the last thing to show for the code is pressing the back button should actually take you back. So on our build options for slot, we'll do a visual element back button equals option container, query for the icon, and back button register click handler. It'll call hide option container, passes in the option container. And in there, we're going to do basically the inverse of show option container, where we're going to add in the class fade out left, remove the class of showing it fade and right, make it not focusable and make the picking mode ignore so we don't accidentally click it, even though it's invisible over the rest of the UI. The rest of this is really just toying with animations and refining the user interface to get a better look and feel. Remember that the full project is available on GitHub to everybody for free. If you need to check out the exact USS styles, or maybe I went over something too quickly and you want to really dig into it a little bit more, feel free. It's available all the time. I hope with this video you see how we can group different modifiers, names and descriptions, all that kind of stuff together to make an attachment system that our players can use to easily swap different perks or buffs, whatever you want to call them, to their guns, to make them have a unique playing style. This gives you a pretty cool way to add a new layer of customization and configurability in for your players that just really deepens the feel of your game. And if you want to support this channel, you can go to patreon.com/LlamAcademy or click join or super thanks right here on YouTube. get your name up here on the screen, get a shout out to the Awesome tier, and some other cool perks too. At the Awesome tier, there's Autumn K, Matt Parkin, Ivan, Rulin, Iffy Obelisk, and Dwarf. At the Tremendous tier, there's Bruno Bozic. And at the Phenomenal tier, there's Andrew Bowen. Thank you all for your support. I'm so incredibly grateful.